Let's take a look at synthetic division. Synthetic division is sort of a shortcut for polynomial long division, and specifically it's intended to divide a polynomial, for example like this one, by a linear factor. In other words, a factor with just x, like this one. And although it works well for that, we're going to focus on a specific application of synthetic division, which is to test a value of x to see if it's a zero of the original polynomial. And in doing so, we can actually decompose this polynomial into smaller and smaller polynomials by testing various zeros. If a number we test is a zero of the polynomial, it is going to form a factor, and it will actually give us the reduced polynomial that we can then repeat the process on, and so on. Well, that's all fine and well, and you may learn how to do that in more detail down the road, but for now what we really want to do is focus on synthetic division, primarily as a means to simply test to see whether a particular value of x is a zero. So instead of actually doing the long division like you see here, we're going to set this up a little bit differently. So the first thing I'm going to do, of course, is decide which number I'm going to test, and we had x minus 2 as the factor we were dividing by, and if you recall that if we have a factor x minus 2, that really represents a zero. By setting this equal to 0 and solving, we see x equals 2, and it turns out that this is the number that we really want to test. So in essence, we're going to take this factor and look at the opposite of this sign, as we often do with these zeros of the polynomials. And so what I'm going to do to start with is first make sure that I have all of my coefficients identified. So I'm going to put ones and negative ones wherever I don't have a number, because that's what's actually there. And if I happen to be missing a term, in other words, I have a cubed, a squared, a first degree, and a constant term here. For example, if this term were missing, I would put a 0 here. I have to have a placeholder for every single term, whether it's there or not. So what I'm going to do now with these coefficients is just write them in order. Be sure you keep track of the negative signs where required. And then I'm going to put a little divider over here, and I'm going to put my number over here. This is the number that I'm going to be testing to see whether that's a 0. I'm going to draw a line down here. And so step one on synthetic division, after you've written the coefficients and your number, is to bring this number down, just as it is. And now what we're going to do is multiply 2 times 1 and put the answer here. Then we'll add 3 and 2, gives us 5. We're going to multiply 2 times 5, gives us 10. We're going to add, multiply 2 times 9, and add. So the process is basically multiply, put the number up here, add. Multiply, put the number here, add. Multiply, put the number here, add. What we're really looking for is this number. This is our remainder. Okay? And we're looking for whether the remainder is equal to 0. If the remainder is equal to 0, then the tested number is a 0 of the polynomial. And if it's not 0, then it's not. It's just that simple. So we see that x equals 2 is not a 0 of this guy. Okay, so now what we're going to do is try a different value of x. In this case, x equals 1. So I've got my coefficients written here. Got my little divider thingy here. I'm going to put 1 over here. Okay. I'm going to draw my line right down here. Drop down my 1. 1 times 1 is 1. 3 plus 1 is 4. 1 times 4 is 4. Negative 1 plus 4 is positive 3. 1 times 3 is 3. Negative 3 plus 3 is 0. The remainder is 0, so x equals 1. 1 is a 0, I keep doing that, of the polynomial. Yippee. Okay, let's do another quick example here, and this is a fairly simple polynomial, and I could probably factor this pretty easily as the difference of two squares and find out that my zeros really should be x equals 3 and negative 3. So I'm going to go ahead and test that just to illustrate the process, and what I really want to show here is, you notice I have a squared term but no x term before I get to my constant term, the negative 9. And so I want to think about this polynomial as x squared plus 0x minus 9. And the reason is because I have to account for this term in the synthetic division. And so now I can go ahead, I can put my 1 here and bring down my coefficients, and you notice that I have to include that 0 here, otherwise this will not work. I'll put my divider over here. Let's check x equals 3. I'm going to draw my line, take my 1 down here. 3 times 1 is 3. 0 plus 3 is 3. 3 times 3 is 9. Negative 9 plus 9 is 0. So my answer is yes. And just for fun, we'll go ahead and try negative 3. So we'll put negative 3 over here. Draw the line. Negative 3 times 1 is negative 3. 0 plus negative 3 is negative 3. Negative 3 times negative 3, lots of negative 3's here, is 9. And again, we get 0. And so again, we have proven that both 3 and negative 3 are zeros of this polynomial.